Hi, this is Javier Encinas. ASDIP Concrete 4 will be released in a few days. It includes the design of bearing walls subject to out-of-plane horizontal loads such as wind loads. This is typical in many commercial buildings, storage buildings, and so on. This is a brief overview of the capabilities of this module in ASDIP Concrete 4. When you open ASDIP Concrete 4 and create a calculation for a bearing wall, you see this template. Basically, all the input information is entered in the left pane and the output is found in the right pane. In this case, I have created an example for illustration purposes. It's a one-story building. It's a concrete wall, 7 inches thick, reinforced with one curtain at the mid-depth of the wall, number 4 at 12 each way. The wall is subject to some loads, dead, 1 kip per foot uniform load, and 2 kips concentrated load every 48 inches. For live, similar load, and I have also created a wind pressure of the 30 psf along the wall. The wall is 16 feet tall with a parapet of 2 feet. The materials is the concrete, 4 KSI. Concrete density is 150 PCF. In the right pane, you can see at a glance, which is a summary of the results just in one page, where we can see immediately that the design is correct. So everything is passing, as shown with these check marks. The program also generates the interaction diagram in a table. And in the Contents tab, we can see more detailed information of the design. If you click here in the Loads tab, and then on the Show Parameters button, we can see more detailed information about the amplification procedure. For every load combination, the program calculates the amplification factor per the ACI code and then calculates the amplified moments. The program also calculates the wall strength and compares the results versus the applied loads. Graphically, it generates the interaction diagram and compares the applied loads versus the capacity. It also shows the nominal interaction diagram and the design interaction diagrams affected by the phi factor, which is reflected in this table. This is the interaction diagram generated by the program for the typical most important points along the interaction diagram. In the Detail tab, the results are shown in more detail, the properties of the wall, the materials, and then the calculation of the loads. Finally, how the loads are amplified by code, and then a sample of the calculation of the wall strength. The program also generates the shear, moment, and axial diagrams by load combination. In this case, the controlling combination is dead and live and wind. In this version 4, not only concrete walls can be modeled, but also masonry walls can be modeled. I have modeled here a masonry wall for illustration purposes. It's an 8 inches block wall, reinforced with number 4s at 16. Is not solid grouted, so only grouted where the rebars occur. In the materials, the nominal masonry strength, F prime M, is 1.5 KSI. The mortar type is type S, and the block type is normal weight. The loads are the same that I applied before, 30 PSF, and some distributed and concentrated loads as dead and live. Just for illustration purposes, you can input any other load as well, and also combine them per code. In the case of the masonry wall, we can see at a glance that the design is okay, is acceptable. All the check marks are in all cases. So with this configuration of 8 inches block, reinforced with number 4 at 16, the design is passing. In the contents tab, again, we can see the design results in some detail. We have the amplified factor loads for every load combination, the applied loads, and then how they are amplified per code. And this is the amplified set of moments per load combination. The program also calculates the wall strength for the masonry wall, the applied loads, and this is the wall capacity. The program also generates the interaction diagram for the masonry wall. This is the masonry wall interaction diagram, which is a very good feature in this module as well. You can see the applied loads and compare the loads versus the capacity. This is the nominal capacity. This is the design capacity. This is a blow up of this area over here. Since all the loads are grouped at the lower portion of the interaction, this is a blow up of this area in a larger scale for easier identification. Likewise, the program generates the shear, moment, and axial diagrams per load combination, any load combination. And also checks the controlling load combination is this one here. So the program is very handy. Also, the program is able to model 2-story walls. In the previous version, only 1 story was covered. In this new version, 2 stories can be modeled as well. In this case, I have modeled a 2-story wall, similar loads applied at the roof and applied at the second floor for dead and live, and also for wind. I'm going to put 30 PSF as well at the bottom. So I'm applying 30 PSF along the wall, the 2 stories, and also in the parapet, and some live and dead loads for illustration purposes. In the interaction diagram, you can see the loads at the first level and also at the second level in the same interaction diagram, which is a very good feature to see how the walls compare to the capacity of the wall. The shear, moment, and axial diagrams are also generated for this case, for the 2-story. Also, at a glance, we can see what is failing. In this case, we can see that the amplified loads are failing, most of them. To see why, we can go to the condensed. Here, we can see that the problem occurs at the first level, because at the second level is okay, but at the first level they are not passing. And basically the issue is that the amplified factor is more than 1.4. For example, here is 1.57, 1.73. Cannot be more than 1.4 per ACI code. Here 10.10.2.1. And this is the way the code controls the thickness of the wall. In this case, it's not passing, so probably we need to increase the size, maybe 7.5. Yeah, with 7.5 everything is passing. If we switch to a masonry wall, we can also see that the 2-story wall can be modeled as a masonry, and the program generates the interaction diagram as well. So now we can see the loads. Probably these are the loads corresponding to the first level, and these are the loads corresponding to the second level with more axial loads. But in both cases, all the loads are inside the interaction diagram, so everything is passing. The diagrams are also generated for this case, and we can see also the numeric calculations in more detail. Here, the amplified loads for the first and for the second levels, the wall strength, and then the interaction diagram. So the program is very handy, and you can also generate your report, the contents report, print preview. Here it is. So we can see all the calculations handy, and also the images, so you can share all this information with your coworkers or your client or your checker. So this is the new feature in ASDIP Concrete 4, bearing walls both in concrete or in masonry. The program is very powerful, very handy, and the user interface is quite simple, very user friendly. Thank you for your attention. We'll see you in the next video.